Hi guys, my name is Jason Kreidner. I'm a co-founder of a nonprofit called BeagleBone.org. I'm also an employee of Texas Instruments. We're known for not just making calculators, but also semiconductor devices, including microprocessors of the likes that are used on the BeagleBone Black. I want to get to know you guys just a little bit. Trying to figure out what's your motivation. How many of you have 3D printers at home already? Okay. Actually, a good number. So a lot of people are getting started with the hobby. How many people want 3D printers? Okay. Those few people that didn't raise their hand. Why are you here to get out of the heat? That's what I was thinking. All right. So sounds like most of you, a few of you are here just to get out of the heat, but a few of you are actually really motivated on trying to get a 3D printer of your own. There's lots of different 3D printers you can start with. There's a lot of different ways to build one. A BeagleBone Black is a fairly advanced way to build a 3D printer today. It's not the first getting started with 3D printers. There's a lot of other kind of off-the-shelf stuff you can get started with. Although this was my first 3D printer, and I love it. It's amazing. I didn't appreciate that as I was loading into the car this morning, I dropped the glass build plate, and it shattered all over, and that's why I'm not actually doing any 3D prints for you here. But I got started with something a little bit more advanced. There's a lot of other cheaper ways to get started with 3D printing, but the BeagleBone Black has some really unique capabilities for those of you trying to kind of take the next step with 3D printing and do some other types of machine control. So there's a lot of people that have a lot of interest. I want to try to kind of serve them a little bit by pointing out to some of the things that are going on with BeagleBone Black and making 3D printers, particularly with this really cool software called Machinekit. How many of you work in an automotive related stuff at all? Good number of you. How many of you have been around machine shops? Know what a CNC mill is? Yeah, okay. Lots of people know what mills are. So there are these computer-controlled machines. It stands for computer numeric control, and they're robots, right? The same like Rosie the robot, the Jetsons. Except a robot doesn't always wander around your house. It's not always mobile. Sometimes it's just something that stays fixed, right? This is a robot, and robots do wonderful things like build cars, but they also make the components. For a lot of things, so you can control a machine with a tool, right, that's going to grind things out. And so this Machinekit software is actually coming from something called Linux CNC, which is an open source. There's a big community of developers that are pushing this software into better places, improving it for people. And Machinekit is a fork of Linux C. So fork in open source software terms means you stole it, right? So it just means that when you do things in open source, right? There's kind of like usually one guy that kind of leads the project, and he kind of brings in everybody else's patches when they have improvements. They have something that makes it better, and you bring it all onto one. But when that one guy stops taking the changes in, like you're doing some useful stuff, and you say, "Hey, guy, this is really good stuff," and he doesn't take it anymore, you have a fork. That means that somebody else is going to start taking in those changes and kind of maintaining their own versions separately. And so there's a nice community forming around a fork of the very good software Linux CNC, but it's to try to address a lot more types of machines, including this thing called a 3D printer. And tech guy. Did I do that?
What happened? Did we lose the computer? Oh, you know what it is?
Power savings. Fantastic.
I don't know how that would have came unplugged, but maybe they did last time. Your computer?
I don't know why I need the screen back on, because I pretty much wasn't using anything there anyway. So my motivation in all of this, of course, is I work on these open hardware computers, right? These things. The BeagleBone is a little Linux computer. It's running in at 1 gigahertz. You can hook up a keyboard, monitor, and mouse to it. Use it like a desktop. Like, how many of you heard of that thing called a Raspberry Pi? Yeah. a lot of you. They, they might have borrowed the idea. I don't. It's a pretty cool thing. The Raspberry Pi is pretty awesome. You know, what's really exciting is that it's getting a lot more people into learning how to use computers, and I love them for that, and making it more affordable and more accessible for more people. We kind of do the same sort of thing. You know, we have this little Altoids 10 form factor. That, you know, they kind of, the Raspberry Pi also kind of chose those sort of outer dimensions and stuff. One of the things they forgot to do was round the corners. So you won't actually be able to fit a Raspberry Pi into an Altoids 10, but you know, they did copy the outer dimensions, so kudos. And the other thing they didn't do is open source the hardware. So that's one of the big things that for Beagle, we're not just doing this so that you know, we can sell more boards, right? Our ultimate goal is that we enable other people to go and make boards and add, like, be a community where other people can share their designs and improve things and fork our designs. And in fact, that's exactly what I'm holding in my hand here. It's in the same form factor, but this is not a BeagleBone Black, it's a BeagleBone Green. This is a company called Seed Studio that took our design, and they made a few modifications. They put their little connectors on it, and now they've got their own board, the BeagleBone Green. So that's what open source hardware and forking can do for you. And so they have that fork. All right, so the slides for this, there's going to be lots of different links to little fun things. So go to beagleboard.org/show. They're actually already up there for the Maker Faire Bay Area, which is pretty much, this is the same presentation. But you know, you can find that. And I'm going to be doing some more updates so that people that see all this stuff and actually want to go build one of these, you can contact me through beagleboard.org/about. I do meetups at I3 Detroit and Ferndale because I live, you know, up in Oakland Township. So if you're actually wanting to try to build one of these printers, I'd be personally happy to help you. You know, do some of that stuff and be putting up resources up on the web page to update that. Let's walk over to the computer and hit the arrow key. Well, it's not flipping the slides. All right. The basics of 3D printing. It sounds like I don't want to spend a whole lot of time because a lot of you seem pretty familiar with that. But it's an additive manufacturing process, unlike that CNC mill, which is subtractive, right? So you're either, instead of, like, you know, at CNC mill, you're cutting off all the pieces and you like start with a big chunk of metal and then you end up with the object that you're trying to design. With 3D printing, you're starting layer on layer and you're building it up. And it's all just like this little thing called an extruder that's spinning out plastic. It's kind of like a hot glue gun, and you just kind of run it all over there until you build up the object. It's much more interesting when the thing's actually running. But there's also some kind of the stereolithography thing. So instead of just doing like a hot glue gun, some people are actually taking projectors and they shine light on this rosin, and that causes the rosin to harden. And they're doing different materials, and that's where some of the interesting innovation is coming from. People are doing some of that with BeagleBones as well. In fact, Full Spectrum Laser is shipping a 3D printer that's using a BeagleBone Black in it today. And it's one of the stereolithography printers. Those are pretty cool. There's lots of different geometries, like, you know, how you build the robot arms. Kind of the traditional is what they call Cartesian. You have an X, Y, and, you know, X is this way, Y is that way, and then Z is that way. But this is what's called a delta configuration. So here, if I want to move back and forth, I have to do a bunch of math to go figure out, you know, how do I move the X coordinate and the Y coordinate equivalently by just moving these guys up and down. And the BeagleBone Black is really good at actually doing that math in what's called real time. I mean, you know what I mean by real time? Golly, I'm in an audience of experts. What's going on here? So yeah, real time just means that I need to do that math in a certain deadline, right? I need to know if I'm going to move this print head, you know, to a different position in a certain time. I need to have already calculated the next position I'm going to move it into before I get to the time where I need to start sending those stepper motor pulses. And so stepper motors, right? So machine control. There's lots of different ways you can control it. And you know, so one of those is like the way this one sounds. It's a stepper motor. So you send these little pulse trains, like you send pulse, 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 pulse. Every time you get one of those, the stepper motor is going to move it just a little bit. And it's very precise, little precision, points, right? It's just step, 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 step. There's other types of motor control, but that's the predominant one used in 3D printing. But we also have things like heating elements and other things we need to control. One of the nice things about the BeagleBone Black is it has these little 200 megahertz microcontrollers that I might have mentioned before. But we actually use those to feed the stepper motors, right? So they're responsible for that precise timing control to send out the stepper motor pulses. And the Machinekit software, you don't actually have to program these microcontrollers. You just configure Machinekit to tell them where the stepper motors are wired up on your board, and then it sends those pulses out in time. And it also does all that geometry calculation stuff in a real-time thread running on the main gigahertz processor. Uses a real-time executive called Xenomai, which is, so that's just to say that the main processor is running Linux, but if I want to do something in real time, Linux isn't real time, so it can't really do those things super, super predictively. So it's running something in parallel to Linux at the same time to do the real-time stuff. And that's why we can do some even fancier geometries like Core XY and Core XZ for these weird articulated robots and stuff, and some of those are meant to be cheaper and just flat out more fun to see objects like robots moving in more weird ways. So the way we're building, there's a lot of different ways to build 3D printers, and there's a lot of people actually building software or firmware for BeagleBone Blacks to build 3D printers. But I've seen most of the kind of the cool stuff is Machinekit. It's because it's so super, super flexible, and it really works. So if you go to machinekit.io, you can just get these images that you flash onto the board. The BeagleBone Black has 4 gigabytes of flash on it. That just means that it runs the operating system directly off the board. You don't have to put another memory card or anything to run it off of it. And they have images for that. You just load it, and it's got this pre-configured software configuration for running Machinekit. And it's based on the same image that we ship with the boards initially, but just kind of adds some of this real-time stuff to it. And one of the nice things about working with Machinekit or Linux in general is, okay, you get started on this nice cheap little board and you love it and you keep using it, but in like, I don't know, it could take like 50 years for this thing to be obsolete or something like that, right? And there's going to be other hardware platforms that run that same software, right? It continues to evolve, and the lessons learned and the things that you're building on is going to run on new hardware. It's all there's that hardware abstraction layer that takes it to new stuff. So if I want to run on a, so the same Machinekit software that runs on a BeagleBone Black also runs on like these large Tormac CNC mills, right? The huge industrial stuff. It's all the same software. And Machinekit is the one that's responsible. How many of you have heard GCode? GCode, yay, what am I saying? You guys know like real time, you guys know everything. So, but GCode is this, it's the language that's used to express those paths, right? So like when you're building a 3D object, it's got the paths that you're moving, the head for doing the printing. And the Machinekit software doesn't generate the G-code, it interprets it, right? So it takes that G-code in and actually does all the motion there. But it also has a nice GUI. So it's actually just a lot more than just a G-code interpreter. So a lot of the firmware for doing 3D printing and stuff is really just doing G-code interpretation. This actually has a control GUI, replaceable interfaces, tons of different interfaces with like real hard push button type of controls, right? This is meant for controlling industrial mills. And so you can just, you can use the BeagleBone Black, hook up an HDMI display and put hard physical buttons on it and make an industrial machine out of it. And lots of different GUIs. This is just one of the example popular GUIs that I'm showing. Right now, when I'm fiddling in my pockets, I'm trying to figure out where my phone is so I can do a time check on myself, but because I don't want to run too much over. The BeagleBone Black is true open hardware. Everything that you need to get started with the BeagleBone Black is included in the box. Over at the BeagleBoard booth, we're having there's some ones set up with Chromebooks. And the software is pretty much what ships with the boards. If you want to get started playing with one, you should buy a BeagleBone Black. Comes with a USB cable that acts as power, network. Even if you're not running Linux, if you're running Windows or Mac, it actually ships with as a flash drive and has the drivers on it and everything you need to get started. It actually has a built-in tutorial system, and everything's all pre-flashed. And so if you want to play with that, you can just look at the Chromebooks that we have out at the Beagle booth and kind of see some of that stuff for yourself. And there's a huge ecosystem of developers around it today. I think we're somewhere sitting around 650,000 or so boards out in the wild. We've got a couple of different manufacturing partners, so it's not so easy for me to keep track anymore. There's a lot of them out there, and there's just a whole lot more of the designs that people have made derivatives from. Yeah, let's try to get away from the sales pitchy stuff. Oh man, this dives right back into sales pitchy stuff. This is one of those cool little motion pads, and this is why like part of playing with the BeagleBone Black and Machinekit is fun, because you can create robots like this. This is the objective of this is to kind of eliminate these what are called linear rails, and it's a bit philosophical why some printer designers want to get rid of them, but there's some practical reasons as well. This is like a 3D printer that's actually able to print a larger percentage of its own components. And that's like this rep-rap sort of mantra, right? So they're actually trying to make 3D printers that can make me more 3D printers. And so that's going to get more people affordable 3D printers. And I think that's a pretty fantastic objective. But some of these, because they're not using these prefabbed linear rails, that can be, a bit more complicated geometry, right? It's not just this Cartesian stuff. And so having a more capable controller in there, like the BeagleBone Black, will allow you to actually drive more complex geometries like this. Yeah. Try to get to some questions because I really don't know how much time I have. Driving a machine fast, it's not just about generating fast stepper motor pulses, right? You actually need to do some math to kind of figure out how to, there's got to be some, the consideration for the cooling of the plastic. There's only so fast you can push the plastic. There's a lot of physics limitation, and that means you have to do more math to sort of figure it out. And one of the things that machine code really excels at is the path planning, right? So figuring out how fast it can go in the various situations. There's one of the interesting challenges that you have. So I've got this really long Bowden tube. That's this tube that takes the plastic in from the top and feeds it down to the extruder at the bottom. And I've got the stepper motor way up at the top. So when I crank down the pressure on the plastic, there's a real delay between when that motor turns and when that plastic shoots out at the end, right? And so like with the more advanced software, I can actually do some prediction to figure out I'm going to have to actually turn that motor ahead of when I need it and stop it before I want it to stop, right? And that's going to let me do some fancier things. So I can maybe heat up my extruder element a bit hotter, run the stepper motor a little bit faster when I actually know when I need to get it to stop, so I'm not just spitting extra plastic out all over the place. And that's one of the interesting challenges and a lot of the things that they provide some tools to do. But now to actually get started, then I need more than just the BeagleBone Black, right? Because as of today, the BeagleBone Black, or even still the BeagleBone Green here, doesn't have the actual stepper motor drivers on it. So I need to wire them up. I can pretty much take off-the-shelf stepper motor drivers from sources like Pololu and these other places that sell these stepper motor drivers, and I can wire them up myself, just kind of point-to-point wiring. But it's easier with something like this. This is what's called a cape. Everybody has their stupid names for daughter boards. They're all just daughter boards, but that's a lot more syllables, and we don't like saying a lot of syllables. So Arduino has shields, BeagleBone has capes, and Raspberry Pi has hats. Yeah. But this is a cape. And there are a bunch of these. If you go to beaglebonecapes.com, you can find several of them, but you can't find all of them. A lot of the ones for 3D printing you'd find on Machinekit.io. Probably I'm going to list off some of the other ones out here, but this is the one that I used, mostly because I have a bunch of them laying around. They're real old. They were designed for the original BeagleBone White, which came back out in 2011, back before there was a Raspberry Pi. Did I mention that? And so this one's been kind of around a long time, but we're giving some of these away at the booth because basically the developer that originally did this has since moved on, and GCode built up a ton of them. They're just sitting over there, so I can actually get a hold of these pretty easy, and so that's what I used. There's some nicer, fancier boards. This guy's gone off and designed newer versions to work with the BeagleBone Black better. This board happens to use some of the same pins that are used for the onboard flash, so you have to disable the onboard flash to use it. But that's one option. This is probably the best option today. It was developed by one of the maintainers of Machinekit, Charles Steinkuhler, and it's called Cramps. Nice, easy to remember name, right? All right. So there's for the Arduino world, there was ramps. And now this is the Cape version of the ramps. And it's essentially the same sort of thing, right? You see you have these breakout here for the Pololu connectors. And I think he's got some extensions and stuff where I think you can drive something like 8 stepper motors with the cramps plus his little add-ons. So that's a good option today. Looking forward, oh, well, here's another good option. This was made by, I think that Henrik Zeller, or I don't remember what his first name is actually, but Mr. Zeller. Henner Zeller. He's out in California? Works for Google? Yeah. He's built a nice one. This is one of the guys actually developing one of the complete firmware stacks for Beagle, so it's something entirely different than Machinekit, but there's no reason you can't use his bumps board to work with Machinekit as well. So that's a reasonable option. But most of these guys haven't really done much in production volume. They're mostly available for hobbyists. Here's one that's actually generated a production one for use in his own production 3D printer called the Thing Printer. And he released this all as open source. It's called the Replicape. That's going to be the next one I'm going to upgrade my printer to. I think the cramps is cool, but this has got some features. There's, like most of these add-on boards have these little screwdriver tuners to actually configure the drive strength of the stepper motors, right? And essentially you turn to it where the motor's hard to move, but like just hard to move, like because you don't want to take too much current, you don't want it to siege up. And so but there's this manual process. And he's actually got it where there's a software process that he can use to actually tune the strength of those stepper motor drivers, and he puts all the stepper motor drivers onto one board. So this is the one that I'm going to try to use to revamp my printer. So I've got a couple of these guys that's around. This one's really nice. He's out of the Netherlands. Somewhere in the EU. I'm trying to remember. And so we had a gentleman in China come along, Shubizong, and take the Replicape design, take the BeagleBone Black design, and hey, it's all open hardware. I'm going to put it on a single board and make a Kickstarter. And that's what he did. And his Kickstarter was successful. I'm really excited about this because he's selling them for $90, which if you know anything about 3D printer controllers, and you're looking at like such a powerful one, that's incredibly cheap. That is a fantastic deal for a 3D printer controller of this caliber. I hope that he can continue to manufacture that. I'm trying to do whatever I can to try to help him get there. I want him to try to, remember the leveraged his work from Elias for the Replicape and get him to support him. But sometimes there's a little bit of communication barrier, but I still have a lot of hope for this board, and we'll see if he fulfills. We've seen lots of pictures of stacks of boards that he's manufactured, and hopefully the quality is going to turn out and be good. But this is going to be very, very compelling for 3D printer makers. And I just threw this one in because I just love Lego. So also, if you wanted to try to build things with Machinekit, you could just use the Lego motors and Lego sensors, and just kind of fun because there's capes out there that you can actually plug in all the Lego stuff onto a BeagleBone Black using EVB. This is also was done by a Kickstarter called Fat Cat Lab. So 3D printing, brand new to me. You want to look at the code that I did to integrate this. It was mostly just configuration stuff, but I've got all my code up on GitHub that I did just to try to configure the printer. Like, there's a little bit of things to understand when you're using a Delta. Like, there's essentially determining this length. You have to tell the software so that it doesn't make it concave or convex, so you have to make it planar. There's a couple of tune screws on this one to kind of make it level, but you want to make it planar before you make it level. Hopefully those terms are clear. But that's one of the challenges of working with the Delta bot. So the particular parameters I found for the CNC, the CME CNC row stock Max V2 are up in my repository. These guys are out of Goshen, Indiana, and they make a fantastic piece of 3D printer hardware. And they contribute to the RepRap community. So I like them a lot. Yeah, so I'm using the Pololu DRV 8825s. Probably not an accident that it's using TI stepper motor drivers. Probably not. And then I tried using both slicer and matter control. Matter control is nicely configured for getting 3D GCode for the row stock. And I just used their standard configurations, and it worked rather nicely. I did find a few things. Machinekit is mostly geared towards mills. There's a couple of M commands. If you're looking at GCode, there's a couple of M commands that Machinekit doesn't understand. I went through the code and commented them out. All right. It was trivial, but if you don't understand a little bit of GCode, right, it might not yet be ready for you. Right. This is really for people that have been playing with printers for a little bit, or at least are willing to spend a little bit of extra time working it out. And this is the issues, right? So the extruder axis, I think, defaults to A, where I think Machinekit expects it to kind of be an E. Just do just letter replacement in the code, M commands, and there's a couple of other GX oddities that I really don't understand, but just really hasn't caused me a couple problems. But the Machinekit community is really addressing a lot of these issues. They're really improving Machinekit to handle the GCode coming from 3D printer slicing solutions. So I think it's probably improved a lot since I upgraded my firmware. My next step, beyond moving to the Replicape, is that I want to go and hook this thing called Octoprint. How many of you heard of Octoprint? Okay, not a lot of you have. It's a web-based control software for 3D printing. So essentially, you put your 3D printer on a network, and you upload your GCode to it. Like you see, you're working your design software, you're pulling things off of Thingiverse. So Thingiverse is this amazing repository of 3D print designs or 3D models that you can just shove to your printer, and you just grab them off there, and you shove the files over a web interface, and it does the 3D print for you remotely. And it has an interface to do capture with webcam, so you can see it printing in progress, kind of give you a little bit of status report, but it gives you that web-based control for your 3D printer. Lulzbot actually did a nice write-up for taking the Lulzbot 3D printers and using Octoprint from a BeagleBone Black. So essentially, they're kind of adding it as a front end. So they take a BeagleBone Black on the network, and they hook up their Arduino-based Lulzbot over the USB cable. But now I just want to do that all in one, right? Where the printer controller and the computer, right, that's doing the control is all one thing. It's in the BeagleBone. So there's no reason we can't just kind of have that running out of the box. So Octoprint is one of the next things I wanted to do. And there's just some other, like I said, Machinekit's a lot more than just 3D printing. So there's some other fun things that I want to do. I want to make the BeagleBone community somewhat like the RepRap community, right? My ultimate goal with this is essentially make self-replicating Beagle. It's just like the the RepRap community wants to make self-replicating 3D printers, so a 3D printer that can print all the components of a 3D printer. I want to make machine controls that can fabricate machine controls. All right, so the process of building up a circuit board is typically this thing called pick and place. So there's essentially a suction cup that picks up a part and places it at the right spot on one of these things called a printed circuit board. So it's called PCB, or printed circuit board. And so if I'm taking the component, putting it on there, and then I need to heat it up, and there's a thing called solder that makes the electrical connections between the board and the traces on the PCB. And so a pick and place machine just picks up the part with a little suction, drops it in the right place, and then run it through like a reflow oven or some heating element to kind of melt the solder so that you get the electrical connection. And there's other people that are using the BeagleBone Black to kind of do some of that, right? So this is actually moving forward. The Bot Factory, Squink is the name of their product, is actually one that prints circuits. So they're doing something different than a regular PCB process. They're actually using a thing called conductive ink to create the traces on the board, essentially create the wires that are making all the electrical connections onto different materials. They can use paper, plastic, different materials that they can create these things, and then they'll go and pick up the components and stick them to those conductive traces. So they can actually make their own circuit boards, right? So again, it's all towards that direction of having BeagleBone Blacks printing BeagleBone Blacks. And that's what they're using, a BeagleBone Black in here to control their machine. There's this is another one of those. I just think it's a little bit more advanced, a little more geared toward professional, right? Because there's only so much you can do with that conductive ink if you actually want to work with standard PCBs. That's what the folks over at Carbide Labs are doing with their pick and paste. They call it pick and paste because there's another part of the process in creating the PCBs, which is putting this thing called solder paste down on the board, right? So I mentioned that you heat it up, the solder melts. We have to put the solder down on the pads where you're going to drop the part. So the pick and paste will actually go and put solder paste blobs wherever they need to be on the board, and that replaces a process called stenciling. As you normally would create a PCB, normally you just create this stencil, and you do this thing where you kind of squeegee like you're making like a t-shirt, like you've seen the process for making t-shirts. You'd actually kind of squeegee the solder paste out on the boards. Here, this is what the machine does. It just goes and squeezes out the solder paste, all the pads on the board, and then it picks up the components and drops them in. But it's using standard PCBs as opposed to this conductive ink. And the guy that actually went and started this up is actually another one of the most maintainers of Machinekit. Now I'm just getting a little off track here, but this is, I did mention earlier about rosin printers. This is more just a fact of a plug of the BeagleBone Black being used in a rosin-based 3D printer. So these guys are making off-the-shelf 3D printer that's pretty affordable, rosin-based, and they're using a BeagleBone Black. You can see it's a nice little Ethernet connector in there, but that's it. That's a BeagleBone Black being used to drive that. The one thing I didn't mention here is kind of fun machines. Is recently there's been somebody that did a desktop CNC mill called Pocket NC. But they did a very limited Kickstarter. They only did like 250 units or so, but it's an entire 5-axis mill using Machinekit, so it can actually grind out aluminum blocks and stuff and cut it from all sorts of different angles and work with different tools. And they're using a BeagleBone Black and Machinekit in order to build that device. So I still haven't gotten the hook. So I don't know if, I guess I'm saying that means I definitely have time for questions. Hopefully I didn't rush too much. What types, so can anybody, like, just, instead of I just open it completely for questions, is somebody working on a project where they're building something with a BeagleBone Black, a 3D printer, or a mill or anything with the BeagleBone Black today? Any challenges they're facing or something that they want to mention to everybody?
So I'm trying to build like a circuit board. So I'm trying to build like a circuit board router using the BeagleBone Black. but one of the main things that I've been finding with the Machinekit, maybe it was just my Googling skills, but I couldn't really find a solid like pinout on it.
So so the pinout, are you talking about the pinout from the BeagleBone Black itself, or how it maps to the different add-on boards or capes that you're working with?
How it maps to the specific capes.
All right. So there's in a Machinekit, there's kind of a library of the different add-on boards or capes that it supports, and it is a bit of an arduous process to kind of do the mapping if your board hasn't already been configured, right? It's real easy if you go and grab the Bebopper and you're looking at like the exact configuration that I have for the row stock, because you can just copy all that from me. The long process, I'd say, is Derek Malloy's written this fantastic book called Exploring BeagleBone, and it has all the details you need to kind of figure out all the different pin mappings, and you look at the schematics of these individual breakout boards, and then you look at what you essentially need is the GPIO number for the different pins. More practically, you want to try to choose those capes that are already in the Machinekit listing, and kind of build on top of those. And if you're not finding it, there's a very nice mailing list on the Machinekit list where you can ask some of the questions about routing. We also have a Beagle IRC channel that I don't know if you've popped in there, but we have a live chat, and a lot of the people in there are somewhat familiar with Linux CNC. And I'd say also come to the i3 Detroit meetups. I'd say absolutely come out to there if you're trying to kind of resolve through some of the mapping issues of GPIO pins to stepper motor drive signals. Lost some people with that one. That's all right. Any like more broad questions? Like, I mean, because I love hearing from people that are actually really trying to get something done. So I love hearing that. But maybe you have some more broad questions. How much does a unit like that cost? Like this. So the See Me CNC guys are out here, so you can ask them specifically. But this is about a $1,200 kit, right? That has to be assembled when purchased. They make a smaller version of this called the Orion. This is the Rostock Max V2, and that's already all right, the hook's coming. That make a smaller version that's already pre-assembled that you can then go in if you want to just replace the electronics that are already in there and working. So that's a really nice approach for getting started with the Beagle. I'm going to be headed to I'll stand outside the door for just a bit, and then I'm going to head back over to the BeagleBoard booth. I really appreciate you guys being patient and your interest. You guys were fantastic. Thank you very much.